All right, and we are live. Hi, everyone, and welcome to SOLIDWORKS Live Design. If you're joining us for the first time, SOLIDWORKS Live Design is a series we run here at SOLIDWORKS that's dedicated to the pursuit of learning from one another using the medium of live demo. And this season, we are dedicated to deep dive topics, specifically topics that are near and dear to the presenter's heart. They'll be sharing their expertise, their knowledge, and we get a front row seat to it all. My name's Noah Zeef, and today we're joined by a mechanical engineer who you may know from his 3D printed mechanical creations on YouTube. It's Danny Lum. Danny, welcome to the channel.
Thanks, man. Hi, everyone. Thank you, SolidWorks, for having me.
Yeah. So we're so excited to have you, Danny. Before we dive into all the amazing things that you've created, can you tell us a bit about yourself?
Sure, yeah. I'm a full-time mechanical engineer. About 4 or 5 years ago, I started making content for YouTube, TikTok, and Instagram, mainly about 3D printing and 3D modeling. Um, First off, I started with like making my own Iron Man suit because that was like the inspiration for me to become an engineer. And then slowly I learned more about 3D printing and electronics. And I really found that my passion was like making custom crazy projects. So I started with, if you play the game Valorant, it's a boombot, which is basically just like a tiny autonomous robot. Last year, I made a Nerf turret that can look for people and then shoot them. Um, and right now, I'm making a mini tabletop bowling lane. So something that can fit on a table, but it's fully automatic and can replace pins automatically. So should be a fun party game.
That's awesome. I feel like that's almost a rite of passage for engineers. You see Iron Man, and now you need to become an engineer. That's how it started for me as well.
Oh, awesome. Glad
Yeah.
we have that in common.
So you have a bunch of cool projects that you've worked on, like you said. I'm just curious because I've seen so much amazing content on this bowling alley. What made you want to take on this project and design this creation?
Yeah, I think I learned like how complicated it was,
Yeah.
and of course, my first thought was like, "Whoa, I want to make that for myself," and also like through making it, teach myself how it works. Um, the thing is, I was definitely way in over my head because this thing is very complicated. But I definitely learned a lot, so it's been a really fun project. I hope people have enjoyed watching my videos and learning about how a pin setter works as well. Um, and yeah, I'm pretty close to finishing it. I keep saying that, but I'm actually really close now. And soon we'll be able to play full games on it, which is pretty cool.
That's awesome. And it's funny, I had the same exact reaction when I was watching your videos. I was like, this is way more complicated than I thought it would be.
Yeah,
Um, it's almost like it's even more complicated making it as small as it is compared to a regular size bowling alley.
right. Yeah.
Mhm.
Like, I feel like people go to the bowling lane to play games and you don't really think about it. Like, the pins just get replaced. But a lot of these pin setters were built like decades ago before they
Mhm.
had 3D printers and prototyping. I have no idea how they did it, but
Right.
they're like, they should honestly be in like engineering museums because they're like mechanical masterpieces with all like the intricate details and mechanisms that are involved.
Mhm.
It's pretty amazing. I actually, the one that I built, there's like a couple different models. It's called the A2 specifically. Um,
Mhm.
is like even older and entirely mechanical. Like they've redone it. There's also versions that are like uh string based, so you knock over the pin now and then like a string like returns it. And I get those
Right.
comments a lot
Yeah.
often now. It's like, why are you doing all this? You could have just used strings. It's like, that's no fun. I don't want to do that.
That's the job of an engineer to overcomplicate things. That's how you
Exactly. Yeah.
know we're doing it right.
That's my job.
Um, yeah, that's our job.
Overcomplicate it.
Right. And unlike those engineers who designed those bowling alleys way back when, who didn't have these tools, you were able to design this whole thing in SolidWorks, right?
Yep. All in SolidWorks. Yeah, I started using SolidWorks in college, which I think probably a lot of engineering students experience. Like, I took like a intro to design SolidWorks class my freshman year, and I don't know, it just like clicked. I was like, this is it. This is what I want to do. And from there, I got into 3D printing, and then just have slowly like taught myself and improved my skills through YouTube and my personal projects.
Nice. Can we see what this masterpiece looks like in
Yeah,
SolidWorks?
let's get into it.
Wow, look at that.
Okay, so this is my SolidWorks model for the mini bowling pinsetter. There's a bunch I want to talk about today, but I learned a lot about how to model efficiently, because there's a lot going on in this model.
Yeah.
So specifically, like I like to model everything in like one part file. And that's like how I've done my previous models. But this model is literally so big that it got to a point where it like couldn't handle all the features. So I had to redesign it more efficiently and think about a way to really optimize it for speed. So I'll take you through how I did that.
How many parts do you have in this contraption?
I couldn't even tell you. Hundreds.
Too many
There's
to
like,
count.
yeah, there's these, I'll talk about it later, but there's these like there's a conveyor here, and then like these chains that are like print in place that have like a bunch of different bunch of components that are like patterned in a line. But yeah, that eats up a lot of the amount of bodies. Okay, so
Wow, that's amazing.
so you can
And
see the level
yeah,
of detail at this top level. But I just want to show you that like, so this is if you imagine like a layer, like a stack of cake, there's like multiple layers to the model. And the way that I do this is to like, so the first time I tried to model this, my feature tree was like over 1,000 features, and it just got like way too slow and bogged down.
right.
So one of the things that I did to remedy that was try to separate all of the design into like different chunks or systems. So this is like the base layer where I build the lane, which is just like a wood plank that I got from Home Depot, and then like plastic. All the gray pieces are like the custom parts that will be 3D printed.
Okay.
So this is like what I call like the lane base, which is like where I uh, attach the wood to the lane so I can attach other plastic pieces to the entire system, and then it builds on top of that. So this base layer, whoops, the base layer is only like a few hundred features, which makes it really, really fast. So I can like still model efficiently. And then every time I want to go to a next system or add another layer of detail, I'll take that part file and use the insert part command. So
I
it
see.
loads in the same geometry with like all of my reference material that I want to use, but doesn't load in all like the feature data that will bog
Right.
it down. So I can just build on top of it and keep adding detail and like maintain speed at different levels, but not slow down my overall model.
Got it. So you're referencing geometry from other parts of your model without taking in all the information that is attached to that geometry so you can maintain performance. Is that
Exactly.
kind of
Yeah.
sweet?
Yeah. And you could keep doing this as much as you want. Like I just to keep it organized, I have this folder of all the times that I did that. So like the base and the bumpers is one level. Next layer of cake, I added the gutters, then the ball return, then the sweep, and then like I call this like final touches, like um things that are just like too detailed to add at lower levels.
Wow. And that's so many more moving parts than I guess I initially thought there would be. It looks like you have chains, gears. Um, can you take us through those kind of moving mechanisms?
Yeah, sure. So, okay, so maybe I'll just start by like giving a general overview
Sure. Yeah.
of how the Pinsetter works, and like how I came up with like scaling and everything for the project. So I thought it should fit on a table, so that kind of like a beer pong, but just not beer pong, like mini bowling. So
Hmm.
like a kitchen table is like 5 feet long. So I found this wood plank at Home Depot. It's like a 4 foot long wood plank, like an inch thick or whatever, 10 inches wide. And then I was like, okay, that leaves another like foot or so for the pin setter behind it. And then I scaled everything based on that. So for the ball, I wanted to use something that like still had like the weight that you need for a bowling ball to like gather momentum. So I found a 2 inch marble. So it's like got a similar
Oh,
weight
yeah.
factor, and all of that is like really important to like how the pins fly. And they call it pin action. So like when you bowl, like there needs to be like the ratio of height between the pin and the ball, and also the weight between the two are really important.
Mhm.
Um, so that was like kind of how I came up with the general scale for the project. And
And
then
do you have some weight in the pins as well?
yeah, so
Okay.
usually oftentimes I always start with like, what's the worst idea possible? Like, that's
You can
not what
only get better from there.
exactly. That's not what goes through my mind. I always think it's a really good idea, and then like either I'll realize myself, or I'll post a video about it and be like, yeah, this was really stupid. I got to revise this. So at first, I'll show you the pin model. But at first, I was like, okay, this is like a pretty small printed part. Like maybe it's like 2 or 3 inches tall. How do I add weight to this? So I was like, oh, like tungsten. Tungsten is great because it's like one of the heaviest elements. So they sell these like tungsten like gram weights that like literally they use for like I don't know, small model projects. So
Mhm.
I took one of those, and then like if you imagine this is printing from like the bottom to the top, whoops. I like paused the print and then added a
Oh, I
tungsten weight
see.
in it,
Okay.
and then the print would finish, and I'd have a pin that is like the right size and the right weight. And SolidWorks is really cool because if you get really good about like adding materials, it'll also tell you the center of gravity and like the center of mass, which is super important for um, bowling pins actually for them to like behave properly. So I actually got like really technical about like, okay, if the weight is a third from the bottom, is living at like a third from the bottom of the pin, like this is where the CG is. Okay, it's too bottom heavy. Now I have to adjust that. But obviously if you don't know, tungsten is also really expensive. Like 20 of those tiny little weights was probably like 20 or $30. So I was like, okay,
Wow.
that's a terrible idea.
Those are some
Um,
expensive pins.
yeah,
Yeah.
exactly. And I was like making mistakes too. I was like, oh crap,
Uh-huh.
now I need more tungsten. I keep running out. Um,
Right.
and also as I was making progression in the project, people expressed interest for building their own pin setters. So I was like, okay, now I need to think of a way to do this like more systematically where anyone in the world could recreate this who maybe doesn't have access to small tungsten chunks. So my better solution was um, the entire project uses the same M3, M4, and an M6 bolt. So I basically just hogged out the middle and allowed for like a cavity for an M6 bolt to
Oh,
be inserted
nice.
through the bottom to
Hmm.
add that weight. And I did the same thing where you can, uh, adjust the mass properties or whatever to get the CG that you want. You can see I hogged out some material here to have the pin behave how I want it to. But now I have a cheap way of making pins that anyone can go to the store and get an M6 bolt. Um, and then this is cool too. This is a so you could print in multi different materials. The
Hmm.
most common material is PLA, but this bottom portion is called TPU, which is like a rubber material. So I have this rubber cavity in the bottom to add some like gripping for the pin, so it doesn't slide, which is also really important. But yeah,
Nice.
now it's like something that can be easily sourced and like made by anyone and more affordable.
I love that. I love that you kept, every designer in mind when making this in case they wanted to replicate it. And I love this is exactly why I love these episodes because when I saw this bowling alley, and I'm looking at all the different moving contraptions. Like, I want to know how that works. I want to know all the thinking that went into that. We're just looking at one of the pins.
Yeah,
And now
okay.
you could already see the layers that went into thinking, just the smallest detail that you probably wouldn't think at first is super complicated, but
Yeah,
it actually is.
there's a ton of detail in this, and like it's funny you don't realize how much detail there is until you like actually dive deep. Okay, so I didn't even explain how everything works. So you bowl the ball. Everyone knows how that works. The pins will fly out. So these are where the pins live, and then the area behind it, I believe, is called the pit. So the pins ride back behind here, and then I'll take a section view, which basically just means you're cutting it in half. If you cut the whole model in half, this is your view at the side. So this is a conveyor, and I have a motor attached to the conveyor. So this here, can I take a screenshot and draw?
Yeah.
Okay. So as you knock pins over, they like fall down here,
Nice.
and then this conveyor is driving to the left. And then what you have here is the pinwheel, this big wheel in the back. And the cool thing about this is that regardless of like the orientation that the pin is falling, so like I have a pin right here. You could have a pin that's head forward or like bottom forward. So like regardless of which orientations it's in, the pinwheel can catch it with these grooves. So I think I have a better view of it. So you can see how these pins in here can get trapped
they're
in those
facing
little
different
grooves.
directions.
Yeah, one of them is head forward. The other one is like bottom up. So as the pins are knocked down, the conveyor pushes them towards the pinwheel. The pinwheel catches them and is just rotating them upwards to give them height, for them to be like cycled to the rest of the pinsetter. And then this is one of the really cool parts where basically, like I said, pins can load into the pinwheel like head first or butt first. But regardless, this is called the turnaround pan. So like regardless of the orientation of the pin, it's always going to land butt down. So let me see if I have a good video.
Is that because of the weight at the bottom of the pin?
Yeah, so the pin itself is bottom heavy, which helps it kind of fall. Okay, let me just find a good video.
And the weight at the bottom of the pins makes a lot of sense, because I'm thinking even if you were to 3D print these things with 100% infill, that 2-inch marble is going to make these pins fly. So they really gotta.
So you saw it. You see that right there. So it's like,
yes, okay,
it's falling out, and because it's bottom heavy, it always wants to land in the same orientation. So basically, this specific shape is able to make it so that the pins are always landing bottom down, which is what you see here. And then there's another conveyor, which I call the cross conveyor, which is actually like pretty tough to build because it's at a 45-degree angle. So like, how do you catch something that's kind of bottom heavy and like give it a decent amount of height? But like literally everything in a bowling pin setter is intentional. Like you said, the pins are bottom heavy, which helps them like ride up this conveyor. So we got to the point where you knock pins over, they go through this bottom conveyor, they ride up the pinwheel. Now they're traveling this way across and up the conveyor, and then they drop into this thing called the turret. So basically, then the turret is catching the pins and then like rotating them to their correct orientations. Sorry, I should have loaded up a video about this before, but
no, that's all right. And just curious, going through this, how accurate is this contraption to a traditional bowling alley? Did you redesign all of this in your own way, the way you thought it would work the best, or did you kind of reference older designs?
Some things I took like 1-to-1 and like, or not 1-to-1 because it's like about 20% scale of the model, but like I mean just basically the same design recreated at scale. And some things I was like, this doesn't really make sense. Let me just like create it in my own way so that it'll be easier to build for other people. So for instance, um one of the reasons why a pin setter is like I said, involves or could be included in like a mechanical museum is because most pin setters use like only one motor to like power all of these different contraptions that are going on. So most pin setters have like a ton of gear ratios and different mechanisms to make it so that one motor can like take care of all the action that I'm describing now. But
Mm-hmm.
I decided, okay, I'm going to make this easier by using more motors and separating some of the motion um, to just like make it easier for myself. And it was still a really complicated project. Um, but
So
yeah,
you use multiple motors for the different moving parts of this assembly.
correct. Yeah. So there's
How
a bunch of
many? Yeah, how many would you say you use in total?
I think like 7. So there's
Wow.
one for this one here that you see controls. So I did some gear ratios to try and limit to not like go overboard with how much like
Sure.
extra electronics would be needed. So this one motor controls that conveyor at the bottom that is pushing the pins to the left. And then this gear train, which I'll go over in a bit, also controls the pinwheel. So that's what is going on the back here. Um, and then it's also through this linkage chain is the cross conveyor. So out of one motor, you get 3 things going on. You get this bottom conveyor pushing to the left. You get this pinwheel turning and pulling pins to the top, and then you get pins like going across this bridge where it goes to this circular, crazy looking thing called the turret.
Got it. So while you did use multiple motors compared to a more traditional design, you still made those motors efficiently contribute to multiple moving mechanisms.
Yeah, as much as I could. Like if it like in here it made sense for me to um try and limit the amount of motors because I could. Um but like also it was kind of like a space constraint thing. Like I can't obviously a real pin setter is much larger. I can't like
Sure.
do what I did here with like complex gear ratios to control everything just because of like the size. It just wouldn't fit. But yeah, where I could, I tried to limit the amount of motors that I used.
Got it.
Okay, yeah. So if you saw in that video, basically the pins are loaded into the turret. They're spinning and they're also like indexing and trying to. So there's 10 pins. It's like catching it and then turning it to its correct position.
Mhm.
And then here,
That is
this
so satisfying to watch.
it's
Those,
yeah,
yeah, those pins being loaded into the turret.
it's filled with like a bunch of really satisfying contraptions.
Mhm.
Um, so then you have the problem of okay, the turret has 10 pins in a circle, but obviously the pins are oriented in a triangle. Like how do you transition them from a circle to a triangle? So the way that it works is I this is like one of the things I'm most proud of. I think this is so cool. Um, so the turret I made in 3 pieces. So this bottom part is what I'm calling the spoons. So the
Okay.
spoons are attached to the blue piece via like uh, a plastic. Here, I'll just hide this. A plastic torsion spring that I printed. So basically, you can imagine that the the spoons can slide out of the way. So like
Mhm. Okay.
as these pins are being caught, once I have 10, um, here, let's see if I show it in this video. The pins can slide out of the way. Did you see
I
that?
see. Yeah.
So and like release them all at the same time. So then after they're released, they they go into what's called the deck, which is like these cone pieces, which is uh I did a really cool thing in SolidWorks. I'll show you.
And is that the part that I guess makes them stand up in that triangle orientation?
Exactly. Yeah. So
Okay.
basically, these cone shapes. Uh,
Yeah, they're almost like funnels.
yeah, they're like funnels that like bring it from a circle to a triangle. So I made, and they're all lofts.
Oh, okay.
So
Yeah, I was going to ask too, did you use surfacing for this or did you stick to more traditional lofting, extruding?
this is just like traditional lofting. I try it like I've done some surfacing like this. Um, I call it the pan. This is surface because it's just like
Yeah.
it's got like a weird bathtub shape, and
Hmm.
if I can and I can model it using solid modeling, I'll do that just because like surfacing is so finicky with like if you tweak one thing, it might break. Like you don't have a ton of control over it.
Right.
Um, but what's it called? Yeah. So
I'm the same way. I lean more towards solid body modeling. I will break out the surfacing if I have to, but if I could get it done with some traditional extrudes, that's where I feel at home.
yeah, I don't know. The simpler the better sometimes.
Right.
So yeah, you can see that like I have this sketch. Here, I'll turn off planes so you could see the sketch. I have this sketch which sort of like catches it at the top here where it becomes a circle. And then I have the circle in the triangle formation, which is like where I know it needs to be. And then the loft sort of does all the heavy lifting to just like transition the shape. And then I use the shell feature to just like hog out the material. My general rule for 3D printed parts is like 3 millimeters of wall thickness is like kind of like the min, or maybe 2.5,
Hmm.
um, just to keep things like lightweight. And then I'll touch more on this in a bit, but yeah, this is another loft. And then I always want to have like I want to do as little work as possible. So like instead of modeling 10 different cones for all the different cones that I have, I recognize that there's like symmetry, and I could use mirroring to make my life easier. So I
Right.
made this part, and then these are all just like patterned around to get the other three.
I see.
Yeah.
Yeah, that probably saves you a ton of work, a ton of features too.
Yeah.
Probably saves on your performance. We got a cool question in the chat.
Yeah.
Have you noticed the same issues with this as you would see in a normal bowling alley? That's a good question.
Um, I think I definitely have. It's funny because like I started making these videos, and then as people were like, "Whoa, that's so cool, like I want to build my own." I also got like so I have a Discord community where people just like join. It's free to join and like come talk and say hi. I probably like 20 different like bowling mechanics that like work at bowling alleys and use these machines daily joined and just like have been giving me feedback and like help with the project. So a lot of the times I'll
Wow.
bump into a problem and they'll be like, "Oh, that's so weird because that's like exactly the same problem that we have in real life." And like the only solution is just like, "Oh yeah, sometimes like a pin gets stuck here." And like the technician just has to like go in the back and release it. Like it just happens. So
Right.
it's pretty funny. I don't know. I bump into like a lot of the answer is yes. I bump into a lot of the same problems. Um,
Mhm.
and yeah, the technicians always tell me it's just like, wow, this is like pretty realistic to real life.
That's awesome. I wonder if you could not only or you were not only able to learn from them about how they go about solving those problems in real life, because it sounds like they're actually experts who make these things in bowling alleys. But I wonder if you were able to help them as well, because you have a tool here that maybe they don't use in a traditional bowling alley, where you could 3D print anything in any
Yeah.
geometry to solve any problem virtually.
Yeah. Genuinely, I have no idea. Like they made this decades ago, and it's like perfect, like mechanically perfect to like solve all these problems. Like, how do you do that? How do you do that
Yeah.
without 3D printing? Like, do you just like keep like modifying a piece of metal until it like gets to where you need to be, and then probably, oh, you made too many changes, now you have to throw it out and start over. Like, I have no idea. How does that work?
Shout out to the traditional engineers, the old school
Yeah,
engineers.
those guys were smart.
They were. We got another cool question in the chat. How did you design the conveyor? Did you? I'm curious because you used mirror tools to kind of save time on making multiple features.
Hmm.
Did you use that for the conveyor as well? Because it looks like that is a lot of repetitive parts.
Yeah. So I'll talk about it quick. This is another thing. I actually haven't talked about this in a video yet, so you guys get some exclusive content for the SolidWorks channel.
All
But
right.
yeah, this is so this is just like a tread that is like patterned a bunch of times. So this is a good use of like teaching yourself and learning on your own. Like, I didn't know how to make uh this was called like a gear and or a sprocket and chain, gear and sprocket,
Yeah.
where you have this thing that looks like a gear, but actually uh, it's a sprocket. And here, let me take a section view. But you can see that. Oops. There you go. You can see that the teeth or the bump outs, the round features on the sprocket or the gear, like mesh perfectly with the treads on the conveyor. So this is something that I didn't know how to do. It took some prototyping, but like I taught myself how to do it originally from a YouTube video that was
Mhm.
just like, this is how you design like a sprocket and chain. I was like, huh, that's really cool. And then
Right.
it took me a few tries, but eventually I got it, because like you have to make sure all of like your patterning is exact, um, in order for things to like mesh properly. And then the thing that I think is really cool is, so similar to like the use of the tungsten to weigh down the pins.
Mhm.
These are really wide treads. Like they're like slightly wider than the bowling lane, which is 10 inches, because it's got to catch pins and the ball uh, on both sides of the lane.
Right.
So like, by what I mean by that is like the treads are wider. Here, I'll take a top down view. You can see that the treads here are wider than the lane itself. It's got to
Yeah.
be like the lane plus like the gutters on the both sides.
Mhm.
So they're really long pieces and almost like don't fit on my printer. But you also have to like connect them through these little holes where they like interweave through each other. And how I did that originally was I was using these like small metal toy axles, but they weren't that long, so I would need like 3 of them per connection. I was like, this is really bad, and once again, this is going to be a part that like maybe not everyone can source. So
Mhm.
what I did was I saw a video. Basically everything in engineering has been done already, and I'm just like leveraging everyone else's ideas to
Right.
get what I want. I feel like
Just
that's
picking and
what engineering
choosing
is.
what could help. Yep.
But I stole someone else's idea where you use a piece of filament as like an axle
Yep.
for a chain. So all of these treads are connected with a piece of filament that you just like put it through, and you connect 2 pieces together, and then you like snip the ends, and that's your axle, and this like whole thing can move together.
I love
And
that.
then I was having an issue where the filament would then start sliding out, because like this thing is moving really really fast,
Mhm.
it's vibrating. So then the tread starts sliding out. So a cool thing that I did, let's see if I could draw it for you guys, was I made like a little,
They're
because
almost
this
like
is
little
3D printed.
alligator
Yeah,
clips.
it's like a
Yeah.
little spring finger. So you can put the filament in, and
Mhm.
because um this piece of plastic can bend as you put the filament in, this piece will like splay outward a little bit, but it'll have enough like spring force where it's still like applying a little bit of pressure on the filament. So it's kind of like it's spreading apart enough so you could put the filament in, but it's
Mhm.
also putting enough pressure on the filament so it doesn't slide out as the whole thing is rotating.
I love that. That's such an efficient use of 3D printing material. Not even 3D printing with it, just actually using the material to help with your design.
Yeah, I was really proud of that.
That's awesome.
Yeah, that
And
was a
we got
cool
a
thing.
question in the chat from a fellow designer who's been on the channel, Jay
And
from
Genezy.
Engineezy.
Yeah.
What filament did you use?
I use mostly PLA, but for the the axle part, I use PETG because it's a little stronger.
That makes sense. And
Yeah.
it just makes so much sense to see this in my prints. I've used that trick before using the filament as an axle, but it
Hmm.
does tend to fall out. So I've just ended up kind of like burning it with a lighter and clamping it to kind
That's a
of
good trick
change the
too.
shape. But
Yeah.
this makes a lot more sense. So you're 3D printing almost kind of a mechanism that locks the filament so you don't have to actually deform it with anything else.
Exactly. Yeah. The burning works too, but the only thing that sucks is if you want to take this thing apart, then you basically have to like break it. You have to
Right.
break the part that you burned to take it apart. This lets you like keep everything the same basically.
Got it.
Oh, another cool thing about treads or gear and sprocket is so these ones, because they're not as wide, um this chain doesn't need like an axle. Um, so this piece is all, you could print this entire thing in place, which is really cool. So if I show all bodies, so like this is how it looks like in the model, but then I made a separate pattern. So that over here is what I would just like send to my slicer to print, which is really cool. And this is the first model that I did that was print in place, which is like a weird concept because you're like, how can something that like moves
Right.
like be print in place? Because wouldn't like all the plastic like bind together as
Mm-hmm.
you're printing it? Like it's a weird concept. Um, but basically, how it works is there's like a tiny air gap. So you leave a small amount of room between the two moving parts, like 0.2 millimeters. And that's like kind of how like support works. Like if you've ever 3D printed and you use support for overhangs, like basically it's material that like prints over like a spot. If you print like a roof shape or like something or like a T shape,
Mm-hmm.
um, you need support material, but the support material has to be removable. So there's a small gap between the support material and your actual part, so that they so it can print okay, but like um, what's it called? Still be like the part that you want. So you leave a small air gap so that you can still separate them after they print,
That's
which is pretty
awesome.
cool.
It's
Yeah,
you hit the nail on the head. It's almost like you're printing in midair for a minute.
yeah,
You know, you're
that's
defying
exactly right.
gravity for a second. I
Yeah.
love how you laid these links out so
Hmm.
you don't have to physically assemble each one. You know,
Hmm.
that's going to make it a lot easier if other people want to make this. And it looks like we have someone in the chat who wants to make this themselves. Chris asks, I'm sorry. Chris asked another question. If we can get that one up, he says,
Sure.
"When will you have the files out there? When will it be complete? When will you have a full bomb with motors and other parts needed? I really look forward to building this."
Thanks, Chris, for your question. Yeah, I am very excited. I keep saying a date and then like I bump into more problems. So
Mm-hmm.
I can't give you a specific date, unfortunately. I'll say that I'm very close. I just figured out the scoring. Um, and pretty soon it's basically just going to be like integrating, so like putting it all together and making sure everything works well with like the software as well. And then I have to make the instructions video and then like a final YouTube video to like fully summarize the project, but we're getting very close.
Got it. Yeah, just seeing the detail that goes into the pin alone, I don't doubt it's a whole process to document this after you're done designing to share this with your community.
Yeah, there's okay, I want to hide this now. See, this is why I had it hidden, because it would make my model look ugly. But
I see. That
yeah,
actually ties in perfectly though, because it looks like you designed it like that to physically see where it would go, but maybe not how it would move. Um,
exactly, yeah. So like now I'll just hide these. This is just for like the the model to print.
I
And I'll just
see.
hide them.
Okay. And then we got Elijah in the chat asking, how do you think through the mechanical movements of some of these parts when designing them? That's a really great question.
Yeah, it's tough because, like I said, like when I started, I had no idea about how bowling pin setters work. So all I have basically is like my community and the people that are like really involved with bowling machines that know exactly how they work. So I'll like go on my Discord and I have like this whole PowerPoint of like all these images. I'm like drawing. I'm like, is this how it works? Is this how it works? And like
Right.
asking them and they'll give me feedback. And then like it's kind of like an iterative process. And then I have to like print things out and test it and make sure it works how I think it or how I think it's going to in real life. So yeah, that's part of the reason why this has like taken so much time on top of working full time. This is still a hobby for me. So um
Right.
but yeah, it's a really involved process. A lot of the times like I don't really know what I'm doing. I'm just like trying things out and like seeing what sticks and what works well. Um yeah, it's like a learn as you go type of thing.
I love it. This is the side hobby of all side hobbies.
Yeah, hopefully one day. But yeah, for now it's just a hobby.
In that same vein,
Hmm.
did you use any additional, maybe their software products or anything else to maybe simulate the movement
Yeah. Okay.
of some of these mechanical components?
That's a really good question. Okay. So I didn't even get to the point where I fully explained how the pin setter works.
Oh,
But
please.
very quickly, I'll
Yeah.
just say that, okay, after the turret, the pins drop into the cones. Then the cones drop down to here where they like sit on these little ledges. And then this entire platform can lower and raise. And then once it lowers and raises, it can drop pins down onto the ground. But that's just for setting pins in between frames. So once you bowl your first throw, is what I call it. I don't know if that's the technical term. In between throw one and number two,
Hmm.
you have to pick up the pins and like pull them up, and then the sweep comes through and like clears all the knocked over pins and then put them back down. So it's
Right.
there's like a lot of things going on in the system. So I'll talk about the part that like picks them up and puts them down, which is
Yeah.
called the scissors, which is this part, which was so time consuming. Oh my gosh. Um, but this
Oh,
was
yeah.
really
Just looking
cool.
at this thing.
Yeah. So
Yeah.
I wanted to try and make this print in place, but everything is so small and precise. It really couldn't be. So all these like little scissor hands. So these linkages are all separate parts, but they're like patterned 10 times around this like triangular path with like circle holes. But basically, what's really interesting about this is like a mechanism with 2 degrees of freedom. So I'll show you what that means. So here's a little video I made. As the pins are like in their circles, notice how when the pins are picked up, it's not recentering them. So what I mean by that is like if a pin is on the outside edge, it's not pushing the pin to the center of the circle that it's sitting within.
Interesting.
It's
Yeah.
respecting its position. So the way that that works is there's 2 degrees of freedom, which is like pretty complicated. But there's this site, really cool site that's free called Motion Gen, which actually Jay and Genesi showed me. Shout out to him. But basically,
Yeah.
you can like push and pull these linkages to create different mechanisms, and then it like live in real time shows you the different result that it'll give you. So
Interesting.
basically, I did this with the scissor mechanism to very quickly determine all like the right lengths of the linkages. So you can see here, this is just like one 1/10 of the entire mechanism. But if I press play, I can drag and like see where the mechanism will close and open. But this is
Gotcha.
pretty tricky because only one of the scissor hands is fixed right now. So this what you're seeing right now is 1 degree of freedom because I have this hand fixed. So if I free that one and then fix this one, it didn't work. all right, this thing's broken. But anyway, what's supposed to happen is both of the hands can like move independently, so that
Right.
once one gets stuck up against a pin, the other one will engage and like meet it where it is instead
I
of
see.
pushing it over. If that makes any sense.
No, it
Um,
does. So
okay.
you're not trying to give the bowler any additional benefits. If they move the pin a little bit, it's gonna stay that little bit over.
Exactly.
Right.
Yeah. Like if you bowl a pin and it goes flying and it's like in a extreme position and not where it's supposed to be, it's supposed to live there and like on your second frame be exactly where it was in the first frame. Who knows if you can even tell at this scale, but that was like a
Right.
tiny small detail that I really wanted to get right.
And
Which
that's on actual bowling alleys?
yeah, yeah, that's how actual
Okay.
bowling bowling alleys work.
Wow, so truly accurate to the real life
Yeah, yeah,
mechanism.
definitely accurate.
That's amazing.
Um,
And a perfect example of something I would never know just looking at this, the type of thinking that went into placing that.
yeah, it's this part was like so complicated, but once I got it, I was like, oh man, that feels so
That's
good.
it.
That's so satisfying.
Nice. We got another question.
Yeah.
What connections did you use? Like screw parts together or threaded inserts and bolts?
Okay. So ideally, if you can in your 3D printed projects, it's like best to use uh, threaded inserts because, uh, like basically, if you don't know, a threaded insert, you put it into the plastic part, and now you have metal threads in your plastic part that won't wear away that you could put a fastener through.
Right.
But because this project is so big and there's hundreds of fasteners, I wasn't going to sit there all day, especially after each of these parts I probably printed like 5 to 10 times by now, just like iterating through prototypes. I wasn't going to sit there and put like 300 threaded inserts into this project. So basically, McMaster has thread forming screws. So they're like screws that are cut out of pitch that are like very not fine, so like spread apart. So they literally make threads in your plastic part as you're torquing them in,
Interesting.
which are
Okay.
great for projects. But specifically for this project, I switched to just like machine screws. So like I said before, M3, M4, and M6 holes in this project.
Makes sense.
And actually, I want to show you another thing that's really cool. Um, talking about what's it called? Talking about like making connections between 3D printed parts. Um, so all these holes that you see, I would in like previous versions of my project, I was like, okay, how do I make a hole? Like I could use the hole wizard, which is pretty helpful. I could just like physically design in a sketch like a circle and like extrude cut it. But then like you don't get some of the level of detail that I want in the project. Um, okay, hold on, I'll show you a better example. So for instance, like this hole is like a counterboard hole. So it has like a little seat for your screw to sit in. But
Mhm.
the way that I make this feature is with an advanced hole, which I really like in SolidWorks. Let me open this up. So this is like a good way to minimize how many features you're using because it like
Let's
combines a
see.
bunch of different features in one. So not
Mhm.
only is it making a counterbore through the first part, it's making so this one you saw like 4 features in there, right? So
Right.
this part has to connect to this part. So this part has a counterbore and then a clearance hole so your fastener can fit through the hole. And then on this side, there's a lead-in chamfer so that when you connect the two parts, the screw can easily find the second part so it doesn't like wobble around and you can't find the hole as you're threading it in. And then this hole is like the tapped hole or the smaller hole that as you're threading the screw down will form threads in the part. So you get like 4 different features all in one feature, which is really nice.
Right.
Um, And obviously talking about like robust modeling and like keeping your model efficient, like really cuts down on like your total amount of features used.
I love that. That's such a perfect pro tip because you're
Yeah.
right. You're basically combining like two extrudes, a
Yeah.
chamfer, a couple sketches.
Yeah.
So that's a really good use case for that.
And then another thing that I like is because this whole project, I tried to be consistent and not use a ton of different hardware. I used 3 different types of screws in the entire project. So I've just loaded those profiles in. So all I have to do is make a sketch for like where the holes are going to live. And then I click like a M4 counter bore. And then I just click that point and it makes it like in a second exactly what I want, which I
Nice,
really like.
nice.
Okay.
And looks like we'll continue on. We want to get to where the pins are finally hitting the what is it? The runway? I'm not a
Oh
bowler,
yeah,
so I don't know the term.
you could just say the lane.
The lane. Oh, that would
Yeah.
make sense. Yeah.
But yeah, I explained like the respotting with the scissors where you like pick them back up and put them down. Um, and then these, what's it called? So this entire purple piece uh, slides backwards and forwards. So this purple piece like lives where you see it right now by default, but it can slide to the right. So basically what that does is if I take a section view, it can store a pin in this cone
Mm-hmm.
and also at the same time have room to respot pins. So like this entire system could hold 20 pins at once because if there's 10 pins in the cones and 10 pins like being picked up by the scissors, it can do that at the same time. But once it's like to put the pins actually on the lane, the purple part can like slide back and forth and like actually like release them from these pegs and like put it onto the lane.
I see.
I can
Okay.
show you quick if I have a quick video.
And while you're trying to find that video, we got a good question. When you're assembling these parts, is the plastic damaged after you screw it in, or can you reuse that part after you actually connect it?
So you have to be careful. Short answer is like that's the benefit of using a threaded insert. Like you can get probably like hundreds or maybe infinite usage out of a threaded insert because it's a metal part. Plastic parts, yeah, the threads are going to deform, but like if you just thread it in carefully and don't use like uh, a drill at like max torque, like
Right.
it'll be fine. Just like thread it in, when you feel it bottom out, like don't push any further because then you're going to strip the threads. But yeah, just like thread it in carefully. And I mean, I've been doing that for like the past few years for all my projects. And like rarely am I throwing out a part because like it's fully stripped.
Definitely. Yeah. Hand tighten with caution when you're
Yeah,
using 3D printed parts, I say.
exactly. Yeah. Um, so yeah, that's how the pins release. There's one other modeling tip that I wanted to talk about. There's a bunch of different, you know, ways or flavors that people model. But as you can see, this purple piece is a separate assembly from this gray piece, but they're like working together and referencing each other and using a lot of the same geometry. So one of the things that I did was to avoid using a ton of features in the same part. Like I said before, which was a problem for me, I made a master file. So basically, what that means is I make one file that has all the reference geometry that I want, and then
Oh,
it's a
okay.
little different than what I did before because before I was taking like 200 features at once, making that one part, inserting that into something else, then building on top of it.
Right.
This is you build all your reference geometry in one part file that all your different parts want to talk to. So they're all talking to the same part. So if I want to make changes, I only have to change this one and then I'll update everything else. So now this lives here. You saw all those planes and where all the pins are living. And then in this part file, I insert that master. So now at the top of the tree, all of my parts that need to reference this reference geometry has that reference geometry all talking to the same part. So like I said, if I want to change one thing, it changes everywhere, and that like limits your inconsistencies and errors in your modeling.
I love that way of modeling. So, and it doesn't even look like it's a crazy amount of references too. It looks like a couple sketches.
Yeah, it's not that complicated, but basically, like I said, because the purple is sliding, it's like the same. What's it called? It's like the same 10 circles in a triangle,
Mm-hmm.
but they're offset about like 30 millimeters from each other.
Right.
So basically, it's like the same shape, just like pushed forward a little bit. So because of that, and actually that changed, like that distance changed because like I realized something. Oftentimes you don't realize things until you build it and it doesn't work. But I had
Yep.
to change that distance, which was really nice. I was like, you know what? I probably have to spend all day like fixing this model, but actually because I set it up this way, I changed, 20 millimeters to 30 millimeters. Everything updates with like minimal errors, saves you a lot of time.
That's a great tip. That's a
Yeah.
great tip, especially when you're working with this many parts and
Yeah.
this many references. It would be a nightmare to change something that you then have to painstakingly change in every other part. But this way, they're all referenced in one. What did you name that master reference?
Yeah, just something with master, just so I knew it was like the control file. And then
Okay.
another thing I really like. So you'll see like there's all these different names. Like I try and give something a name, and then I have rev, which is just like revision with a number. And this is all the way up to 32. Like honestly, I've made like 32.1. Like I probably made a
Right.
hundred different versions of this file. But I really like pack and go in SolidWorks.
Mm-hmm.
So where is it? Pack and go. So say you want to make like a big systematic change to your model where, if you change something, it's like a really big change where like you like how things are, but you were like, oh, what if I change this one thing? That might actually be better. But if I build it wrong, that might break everything. So really I want a whole separate package of files just to, sandbox, try and work in without breaking my existing working model. That's what I use this for. So because everything
See.
has Rev 32 at the end, I'll what's it called? I'll do replace text with, and I'll just do like, oh, Rev 32. I'll just replace that with Rev 33. And now all these files update from Rev 32 to Rev 33, like the file name. And then I'll just like make a new folder, Rev 33.
I see.
And now like all these files would be placed here. They keep their relationships to each other and don't break it all. And it's like a whole separate set of files that you can work in without changing or breaking your existing set of files that are already working well.
That's a great pro tip. Masterclass today, and not just design, but also file organization,
Yeah.
data management for sure.
It's important to stay on top of it, especially like as you're prototyping and making like so many different iterations of all these different parts. It's like you can get lost easy. So you have to stay organized.
Right. Speaking of the crazy number of parts, we did actually get a comment earlier on from one of our SolidWorks experts, Eric,
Okay.
and he actually highlighted maybe we could do it because I'm curious. Maybe some people in the chat are curious how many parts are in this model. I know you said you were so bogged down with designing it that you hadn't found out, but he says you can go to Tools, Evaluate, Performance Evaluation, and scroll to the statistics section.
Statistics. Parts. Number of bodies, 1553.
Wow. There you have it, folks.
Yeah. But like you said, or like I showed you prior, like all of those aren't unique parts. Like even in the chain, like I patterned more bodies just to like make printing easier. Like all of those aren't like actual bodies that like
Right.
are in the Pinsetter.
Right. Some are references.
Yeah.
Gotcha. Awesome. Well, I mean, I could talk about this stuff all day, but we are almost at an hour. Danny, any last things you want to mention to our audience that has had so many great questions today? Shout out to the chat. Really awesome questions. Any last things you want to leave us with?
Yeah, thank you guys for watching and joining the SolidWorks Live about my Pinsetter. If you're new here, welcome. Yeah, hopefully I can finish the project soon and wrap it up for you guys so you guys can build your own Pinsetter if you want. But yeah, I guess my message would just be like, if you want to learn in SolidWorks, YouTube tutorials are great. Classes at school are great, but the most that I've ever learned is from just like getting my hands dirty, making something. Sometimes you have to like print something and test it in real life to like see how it's gonna behave. Like if you want to build something and learn, like just start building. That's the best way to learn, especially with engineering and passion projects. Like a lot of this knowledge that I have, I have a whole list of things to talk about. I didn't even get through. But a lot of the things that I'm talking about, I've just learned through trial and error, teaching myself through these like really detailed projects that I enjoy, and hopefully other people enjoy watching my struggles as I build these projects.
Yeah, no, I think it's a great thing to highlight too. What I love about your videos is you don't just show all the great things that worked, but you show some of the areas where you had to learn along the way, some things that didn't work the first time around. And to hit on the things that you didn't mention, we already have someone in the chat asking for your Discord. Where can they continue the conversation?
Yeah, I can. What's the best way to do that? If you go to my profile, if just Danny Lum on YouTube, there should be a link for it. Or I could send SolidWorks the link. Maybe we could put it in the description.
You could definitely do that. And yeah, there we have it. If you don't follow him already, Danny Lum, he's at Danny Lum Creative on YouTube. I've been following him since before I even found out he was going to be on this channel. So I highly recommend checking out those projects. Not just this bowling alley, but I really like the 3D printed flowers that you did.
Oh, thanks, man.
Those are really nice. So yeah, again, thank you so much for joining us today. And really, almost it seems like it just scratched the surface.
Yeah. Honestly, this was like a summary, but yeah,
right.
Hopefully it shed some light on why this was so time consuming. There's a lot of detail, and I wanted it to make sure that it was like easy to, not easy because this isn't an easy build, but like as easy as it could be to recreate this for someone else.
Right. So yeah, I know many people will be looking forward to that documentation when it's ready.
Yeah.
So thanks again, Danny, for joining. Thank you to the chat for joining us. And we will see you next time on SolidWorks Live.
Sounds good. See you later.
See ya.